Hello and good morning to everyone. So today's lead code question is 3699, which is number of zigzag arrays part 1. So basically in this question we are given three integers n, l and r, right? And what we need to do is we need to find a zigzag array of length n which has these three rules. The rules are that all the elements in the array should lies in the range L to R, right? So this is the condition number 1. The condition number 2 is no two adjacent elements in the array should be equal. So adjacent elements should be different. So this is the condition number second. And the third condition is that no three consecutive elements should form a strictly increasing or a strictly decreasing sequence. So these are the three conditions which makes the array as a zigzag. And then what we need to do is we need to return the total number of zigzag arrays that we can form using form of length and using these elements L and R. And it is given that answer can be large, so we have to use modulo 10 ki power 9 plus 7. Now what is a strictly increasing sequence? So suppose if we have 1 5 7, so we can see first we have 1, then 5, then 7. So this sequence is increasing sequence, right? This sequence is increasing 1, then 5 and then 7, right? Similarly, what is a decreasing sequence? Suppose we have 7 5 and 1, we have 7 5 and 1. Then if we see 7, then 5 is smaller than 7, 1 is smaller than 5, so the sequence is decreasing. So this is strictly increasing and strictly decreasing sequence, right? So let's see the examples to get the question more clearly. So here we have n is equal to 3, that means we have to make the arrays of length 3, and L is equal to 4, R is equal to 5. That means the elements in the array should lies in the range 4 comma 5, right? So let's see. So what can be the possible arrays, right? So the conditions is the element should lie in this range and no two adjacent element can be same. So suppose if we put 4 here, then what are the possibilities for here? Can we put 4 here? No. Then these two elements, adjacent elements, should not be equal, so we have to put 5 here. Then what is the possibility for here? Again we can't put 5 here, then what is the option? We have 4 as the option, so we get one array. Then what if we put 5 here, then we can put 4 here and then again 5. So these are the only two possible arrays that follows all the given conditions, so our output is 2. Then let's see the next example. So in the next example again our n is equal to 3 and L is 1 and R is equal to 3, right? So let's see. So suppose if we start, the first element is 1, then what are the possibilities for the second element? So the second element can be either 2 or it can be 3 also, right? So in this case, now what is the possibility for the third element? Third element can be 1. What if you put the third element as 3, 1 2 3, then we see this is strictly increasing sequence, so this array is not possible, so we get one arrays 1 to 1. Now here what are the possibilities? Can we put a 1? Yes, we can put a 1. Can we put a 2? Yes, we can put a 2 also. Can we put a 3? No. Then these two elements, then 3 comma 3 will be the adjacent elements will be equal. So when we start from 1 we get these three possible arrays. Then when we start from 2 we get these 4 possible arrays, and when we start from 3 we get these 3 possible arrays. So the total number of valid zigzag arrays are 10, right? So our answer is 10. So let's see the constraints. So here n, which is the output length, or which is the array length that we have to form, can be anything from 3 to 2000, right? And the values of L and R also belongs in the range 1 to 2000, right? So here if we see n is small only, right? So let's see. So let's move to the approach part. So as we know, in the question we are given two different conditions. The condition 1 is that no adjacent element should be equal, right? And the condition 2 is that no three consecutive elements can form a strictly increasing or a strictly decreasing sequence. That means if you have three elements A, B and C, then they should not form sequence like this: A is less than B is less than C, or A is greater than B is greater than C. So these three elements should not form a sequence like this, else our array will not be zigzag. So if we'll think in the terms of direction, right? So suppose we have this element, these are the elements. Now if we see the adjacent pairs, so 1 and 5, so 1 is greater than 1 is smaller than 5, means 5 is greater than 1. So the direction is going in the, so we are moving in the upward direction, 1 then 5, right? Then we see 5 and 3, so we are going in the downward direction. Then from 3 we are going in the to 7, that is in the upward direction. Then from 7 we are moving to 2, that is again downward direction. So if we see here, what is the directions? So the direction between the adjacent pairs are up, down, up, down, right? In this way, up, down, right? Now let's take another example. So here we have 1, then from 1 we are moving to 4, that is up direction. Then again from 4 to 7 we are moving in the up direction. So here the directions are up, right? And if we see, these three elements forms a strictly increasing sequence, and it is given to us that no three consecutive elements should form a strictly increasing or a strictly decreasing sequence. So if when our directions is equal to, if we have in the direction, if we have up and up, then that is not allowed, right? Because in that case we get a strictly increasing sequence. Similarly, if we get directions is equal to down and down, directions is equal to down and down, in that case our sequence will be strictly decreasing, so that is also not allowed. So from these examples we have observed that our directions in the result should be alternate. It should be either up down and so on, or it should be down up. So these should be the directions between the adjacent elements in the answer array, right? So now our entire focus will be on these directions, right? So this is one observation. Next we will see that, now suppose we have the range of L, let's say L is 100 and R is 102. Now as we have seen that we only care about the directions, that is up and down direction, right? So what are the possible values in this range? That is 100, 101, 102. Now if we compare these values with 1, 2, 3, so if you see the order here, here also the order is up and up, and if we compare here, here is also the order is up and up. So if we see the direction ordering in these two cases, then the direction relationships are same, right? So what we do is, no matter what is our what are the elements in our range, now what we'll do is we'll shift the range, that is suppose we get from L to R, then we shift that particular window from 1 to M, where M is L minus R, sorry, R minus L plus 1, where M is R minus L plus 1. So here what we have done is we have shift this window towards 1, right? Because we do not care about the actual values, we only care about the directions between the adjacent elements, right? So that's why we have shifted these elements towards 1, right? So I hope you get the 2 points. One is the points in which we have seen that we need the alternate directions in the answer, that is up down or down up, in this way. And then the second point is that we have shifted the actual range from 1 to M, because we don't need the actual values, right? So these are the two things. And now as you have seen that what we need up down. So now what should come here? So here if we have down direction, then the next direction depends on the previous, so whatever direction that we get, it depends on the previous value, right? That is what is our last direction, right? So our future decisions, right? Our future decisions or our current decision depends what is our last direction, that is if our last direction is up or down, and what is our last value. So if you see that our current decision depends on the past, so it will points towards dp, so we'll be using dp over here, right? So let's see what will be our dp states. So first state is we have taken a up array where up of v will tell the number of valid arrays that will end with value v, and the last move was up, right? Last move was up, so up of v tells the number of valid arrays that are ending with value v and whose last move was up. So let's see an example to understand it. So suppose if our last element is 3, and then as we can see 3 is greater than 1, that means last move is up and it is ending at 3, so it will store this in up of 3, right? So this is a valid array, so it will contribute this array 1 comma 3 will contribute to up of 3. So again up of 3 will store the total number of valid arrays that are ending at value v and whose last move was in the up direction, right? So this is up of v. Similarly we have down of v also. We have down array that will store the number of valid arrays that are ending at value v and their last move was in down direction. Suppose if you have the arrays 5 3 and 2, so this is not a valid array because this is a strictly decreasing sequence. Suppose we have 5 6 and 2. Now see it is ending at 2 and the last move is 6 is greater than 2, so from 6 we are going to 2, that is in down direction. So this array 5 6 2 will contribute to down of 2, right? So these will be our two dp states, that is up and down, where up will store the number of valid arrays that are ending with value v, and the last move is in up direction, and the down will store the number of valid arrays that is ending with value v and the last move is in the down direction. So these are the two dp states. Now next we will see the base case, right? So suppose we have values 1 to 3, right? We have values 1 to 3 in our range. In our range we have these three different values. Now suppose if we see for value 3, how many arrays that will end with 3 and the last move should be in the up direction. So as we know, see our last element is 3 and here we want up direction, so all the elements that are smaller than 3 should come here, right? In that case only we get a up direction. So here what are the elements smaller than 3, that are 1 and 2, so we can see 1 comma 3 and 2 comma 3 are the valid arrays, that gives us up direction and our array is ending with 3. So what is our answer? Answer is 2, which is v minus 1. So here v is 3 and 3 minus 1 is 2, that is our answer. Because for up direction, we only want the smaller elements here. So if our value is v, then how many elements are smaller than v? That is v minus 1. So for the base case up of v is equal to v minus 1, right? So for the base case we store up of v is equal to v minus 1. That means all the smaller elements from v, all the elements less than v, right? Now similarly if you see for value 2, how many arrays that ends and 2 and the last move should be down direction. So we know here our last element is 2 and we want a down direction. So here the previous element should be greater than 2 for the down direction. So in the we have values 1, 2 and 3. So how many values are greater than 2? How many values are greater than 2? So that is only 3. So we get answer is 1. So if we see, we have total m values. We have total m values in the range, right? And our current value is v. Then how many values are greater than v? That is total values m minus v, right? So in the base case, we store down of v is equal to m minus v. That is all the elements that are greater than v, right? So these are the two base cases where in up of v will store v minus 1. That is all the elements that are smaller than v, and in down of v will store m minus v. That is all the elements that are greater than v, right? So these are the base cases. Till now we have seen the base cases. So next what we'll see is how we'll transit from one state to another state, right? So how our dp states will do the transition from one state to another state. Now let's say, suppose currently what we have, currently we have 1 and 3. So here we see this is in the up direction, and next as we know we need up down alternate direction. So here what we need, so our future direction should be down direction. Our future direction should be the down direction, because our previous direction is up direction. So we see a new down state will be created here. That means if we see, to create a down state, to create a new down state, what we need, we should come from an up state, right? To create a new down state, we should come from a up state, right? So here what we are doing is we are creating a down state. Now let's say here we get a value x. Our new value that we put here is x. So that value is, here what we are doing is we are creating a down state, and here what is the value that we have value 3. So the new value x should be less than the previous value, to, as we are creating a down state. That means x should be less than 3 here. X should be less than 3, right? So what we are doing is we are creating a down state, so our new value, that is x, should be less than previous value, right? And so new down state for the value x is basically the sum of all the up state of v where v is greater than x, right? So let's say we have 3, 5, and here, so what are the values that we can put here? Here this is up state, we want a down state. So here we can put 4, here we can put 3, here we can put 2, here we can put 1, right? Because we want to create a down state. So our previous value is, let's say, v, right? And here we are putting x. So x can be all the smaller values, that are less than the previous value v. So here we'll put the sum of all the up state, because up of will store the valid arrays that are ending with v and having an up state, right? So we get our new down state. And now see here what we need to find the sum of all the up values here, sum of all the up values to compute this down state. That means to compute the x state, here we need the up state. So what we need the sum of all the, so to find sum of all the up values of v, we'll use the suffix sum, right? Now similarly, to create a new up state, new up state, we should come from a down state, right? That means a new value should be greater than previous value, because we need to move in the up direction. So whatever a new value, that should be greater than the previous value. So new up of x will be the sum of all the down state of v where v is less than x, right? Where the previous value v should be less than x. So here, if our x is equal to 5, then what can be our previous values? What can be our previous values? Previous values can be 4, 3, 2, 1. So we need the sum of all the down state of these values. So then to find the sum of all the down state of these values, we'll use prefix sum over the down array, right? Now let's see an example to get this more clearly. Suppose this is our downs array having value these 0, 5, 7, 2, 7 and 1. And now what we want? We want new upstate for 4. New upstate for 4 means our new value x is equal to 4. Then what should be our previous values? So previous values can be 1, 2, 3. So this is up of x is equal to 4. So here we want down of the previous values, because to find the up state we should go from a down state. So we want down of 1 plus down of 2 plus down of 3, right, to find the new up of 4. So this sum, if we do the sum by iterating over the down array, then our time complexity will be big of n square, right? So to reduce the time complexity, what we'll do is we'll use prefix sum and suffix sum, right? So if you see the overall algorithm, so first of all what we do is we shift the range from L to R to 1 to M, where M will be R minus L plus 1, right? So first of all we are shifting the range, and then what we'll do is then we'll initialize the two arrays, up array and down array, and then this will be our base case. So for the up array, we have seen up of v will take all the smaller elements that are smaller than v, that is v minus 1, and then down of v will take all the elements that are greater than v. So here total elements are m, so elements that are greater than v are m minus v. So these are the base cases, and the base case represents the array valid arrays having length 2. Now using these base case, we'll start computing all the valid arrays from length 3 to n, right? We'll compute or we'll build all the arrays from length 3 to n. And as we have seen to find up of x, what we need down of 1 plus down of 2 and so on up to down of x minus 1, right? We want this. So what we need prefix sum over the down array. So first we'll build the prefix sum of the down array. Similarly if you have to found down of x, then we need up of x plus 1 plus up of x plus 2 and so on, right? And so on. So we'll build the suffix sum of up array, so now if you have to compute new up of x, so that will be prefix sum of up to x minus 1, prefix sum up to x minus 1. Similarly if you have to calculate down of x, then we need suffix sum of x plus 1, right? So once we compute the new up and new down array, then we replace our up and down with the new up and new down, and then at the end, once we have build the array up to n lengths, then what we need the final answer, that is the total number of valid arrays. So that final answer is total summation of up of v plus summation of down of v for all the values v in the range 1 to m. Because up of v, because every valid array can end with any value v, right? It can end with any value v, and with that value we can have either up direction or down direction, right? So that's why we are taking summation of up of v and down of v. So that is our final answer. So if you see the complexity of this approach, so here we find, first of all we find m is, that is r minus l plus 1, and then for each of the n lengths. For each of the n lengths, what we'll do is we'll build prefix array, we'll build suffix array, and we compute then we compute for all the values from 1 to m. So the time complexity for each of the n, the time complexity is m. So the total time complexity is big of n into m, and we are storing up and down prefix and suffix having size m plus 1. So the time space complexity is also big of n, right? So let's try to understand the whole approach with the help of an example, right? So here we have taken n is equal to 3, l is equal to 1, and r is equal to 3. So our m is equal to 3 and our values is 1, 2 and 3. So first we'll compute the base case, that is the valid arrays having length 2. So up of v is basically v minus 1, right? That means valid array is length 2. So up of 1 means the array is ending with 1, and the direction is up direction. So we want a smaller element less than 1 here. So if we see in the range there is no elements less than 1, so up of 1 will give us 0, that is no smaller element. Then we need to calculate up of 2. Up of 2 means there should be a smaller element than 2 here. So what is the possible element? That is 1. So up of 2 is 1. So up of v is basically v minus 1. Then up of 3 is 2, that is 1 comma 3 and 2 comma 3. So we find the up array. Then in the base case we will find the down of v, right? That means here the element value is v, and then the last element is, sorry, down means this side, down. So the previous element should be greater than v. So down of 1, so we have two elements greater than 1, that is 2 and 3. So down of 1 is 2, then down of 2 is 1 because we have only 3 which is greater than 2, and down of 3 is 0 as there is no greater element or bigger element than 3. So we compute down of down array also. So we get, so from here we get up is equal to 0 1 2 and down is equal to 2 comma 1 comma 0, right? And now using these arrays, that is these are stored all the valid arrays of length 2. Now using that length we will compute the length arrays of length 3, right? That is the new up and new down array, right? And as we have seen, what we need the prefix and suffix sums, right, to compute the new up and down. So first we'll find the prefix sum of the down array. So what will be the prefix sum of the down array? So 0 plus 2 is 2, 2 plus 1 is 3, and 3 plus 0 is 0. Sorry, 3 plus 0 is 3. So 0 2 3 3, 0 2 3 3 is the prefix sum array over the down array. And then we need the suffix sum of the up array. So up array is 0 1 2. So suffix of 3 is 2, then 2 plus 1 is 3, 3 plus 0 is 3, and then again 3 plus 0 is 3. So we find this suffix array also, that is 3 3 2 and 0, 3 3 2 and 0. Then what we'll do is, then we need to compute new up array, right? So new up of x, that means this value is x. So here we need in the up direction. So what will be our previous direction? If the current direction is up, then previous direction should be down direction. So to compute the new up of x, we'll use here. So what value should be present here? So our previous value should be less than x. Previous values should be less than x because our current direction is up direction. So we want all the down values of less than x, that means prefix of x minus 1. So new up of x is equal to prefix of x minus 1. That means up of x is basically down of 1 plus down of 2 all over up to down of x minus 1. So if you have to find new up of 1, that is prefix of 0, that is 0. So similar this way we will find the new up array. And then for, as we know, to find the new down array we need suffix. So using that suffix array we will find the new down array also, right? And as we know our n is equal to 3 only, so this new up and new down arrays are storing valid arrays of length 3. So now what we need, we need to find the total valid arrays. So new up is 0 comma 2 comma 3, and new down array is 3 comma 2 comma 0. That means the arrays ending with value 1, all the arrays ending with value 1 and having up direction is 0, having 0 count. Then all the arrays ending with value 2 and having up direction are 2 times. So these are the 2 valid arrays. Then these are the 3 valid arrays. So we get 5 valid arrays from the up direction and we get 5 valid arrays from the down direction. So the total valid arrays are 10, right? So we can even verify with the samples, right? So the valid arrays with starting with 1 and ending with 1. So this is 2 comma 1 ending in the down direction, 3 comma 1 ending in the down direction. So if you'll see here, down of 1 is 3, down of 1 is 3. So these are the two arrays that are ending with 1 and in the down direction, and this is the third array ending with 1 and in down direction, right? That's why down of 1 is 3, right? So if you see the count of these valid arrays, the count is 10, count is 10, right? So here also, whatever answer that we have get from our approach, the same answer that we are getting from the valid arrays. So that means our approach is correct, right? And we'll see the code part. So we have taken mode, which is 10 to the power 9 plus 7, and then we have taken m, which is r minus l plus 1, because we have shifted the range l to r from 1 to m. And then we have taken our 2 dp arrays up and down, and then this is our base case. So in the base case we'll compute all the valid arrays of length 2. So as we know, for the up array we need, if the end value is v, then all the values that he present here should be less than v. So up of v is v minus 1, because all the elements lesser than v are v minus 1. And then for down of v will compute m minus v, because if this element is v and we want the down direction, then the all the elements that are present here should be greater than v. So the elements that are greater than v are m minus v. So we get our base case. Now using base case, that is all the valid array of length 2, will compute the arrays from the length from arrays of length from 3 to n, right? And then we have used prefix and suffix arrays, and then new dp, new up and new down arrays. Then first we find the prefix array, prefix sum of the down array, and then suffix sum of the up array. So watch out the full approach to see why we are computing prefix over down array, suffix or up array. And then what we'll do is, then for every x from 1 to m, for every x from 1 to m, we are computing the new up array and the new down array, and then pointing the up array to the new up array and down array to the new down array. And then once we compute the arrays up to the length n, then we find the final answer. And as we have already discussed, what is the final answer? Final answer is up of v plus down of v for all the values v from 1 to m, from 1 to m. So using this loop we will find the final answer, and at the end we return the answer. So I hope I am able to explain you the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.